Okay, Jai Hind everyone. So today we'll be starting with the first chapter of your math syllabus, that is real numbers. Prior to this, you have studied in class 9th the first chapter, which was, I hope all of you remember, which was the first chapter which you had, number system. So we'll start with the basic intro of what you had in your class 9th. So first of all, how many types of numbers we have? So first, the most basic numbers that we have are your counting numbers. So those are 1, 2, 3, 4 and so on. And these are called natural numbers. Now, what is the digit that we are missing from here that we use in our day-to-day lives? We use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0 is missing from here. So when we include 0 to this group, it becomes whole number. Now since we have included all the positives including 0, now we will be including negatives. That is negative counting numbers. So let's say it comes from negative infinity and now it goes to minus 2, minus 1, 0, 1, 2, 3 and so on. This is what we call integers. Okay, so now we have concluded, now we have included the counting numbers right from 1, 2, 3, minus 1, minus 2, minus 3, 0. Now what is left as of now? That is your decimals and fractions. And they come in the category rational numbers. Though decimal you have irrational also, but now we are talking about only rational part. So you have all these natural, whole and integers, it comes under rational numbers. Now we have other type of numbers, what you call irrational numbers, and the entire number system including such numbers is what you call real numbers. I hope it is clear. So counting numbers are 1, 2, 3, 4. When you include 0, it becomes whole numbers. When you include negative counting numbers along with the positive ones, it becomes integers. And when you include fractions and decimals excluding non-terminating and non-repeating, it becomes rational. Apart from rational, we have irrational, and this complete system of numbers is what you call real numbers. Now, so here our focus is what is rational and what is irrational. So I'll start with what is rational number. So we'll just clear the board. Okay, now, so what do we understand by rational number is something which is of prime importance. Let's see now. So when I say rational number, what do I mean by that? I mean any number which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0. Also, P and Q are co-primes. So the most important thing, what do we understand or what do we know about the word co-prime? I hope all of you know what are prime numbers. So prime numbers are those numbers which have only two factors. Either it's 1 or the number itself. Now co-prime means whenever you have anything in the form of P and Q, it has no common factor other than 1. So any such number which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0, Also P and Q are co-prime. This is what you call rational numbers. Now the point is that why Q is not equal to 0? What will happen if Q becomes 0? Okay. Let's say if Q becomes 0, then P by Q becomes P by 0, and any number divided by 0 is what you call undefined or infinite. Now, what will happen if P becomes 0? Let's see. So, if P becomes 0, then P by Q becomes 0 by Q, that is 0. So, any rational number which can be represented in the form of is called rational, and when numerator becomes 0, the entire number becomes 0. Now, we'll come to the application part that we have to study in this chapter. I hope this is clear to you all. Now, we'll move straight away to the application part. Okay. So, the first and one of the most prime topics of this chapter is Euclid's division lemma. Okay, so what is Euclid's division lemma? Euclid is the name of the scientist who gave this set of theory which we'll just discuss. Division is, you know what is division, and lemma is a kind of standard theory or concept. Now, one more term that you will find in book is, instead of this lemma, you will find the word algorithm. So what do we mean by the word algorithm? Algorithm is nothing, it's just the application of the standard theory in the form of certain set of steps to be followed to solve a problem. So now the point is, you understood the meaning of lemma, you understood the meaning of algorithm, but what exactly it is? Now let's see that. Okay. All of us have been doing the mathematical division right from our basic classes. So let's have a look. Let's say I divide any number, let's say 35 by 8. How many times the nearest factor of 8 near to 35 is 32. So this is what you call divisor. This is what you call quotient. This is what you call dividend. And this is what you call a remainder. I hope this is clear to all. Now, we know one, like from our basic concepts, that dividend is equal to divisor into quotient plus remainder. This is what we have been aware of, like we are well aware of from our basic concepts in mathematical division. Now, I'll tell you a case, try to understand first. Suppose, I'm just taking an example. Suppose I divide 20 by 5. The remainder is 0. Have a look at the remainders, that is of our prime importance. Now let us say I divide the next number 21 by 5. The remainder becomes 1. Now the next number. Now the remainder becomes 2. Now the next number. Now again the remainder becomes 3. Now the next number. Remainder becomes 4. Till here it's all correct. It's all correct. Now one more. Is it possible to have a remainder equal to divisor? No. Our division becomes wrong, because if the remainder is equal to divisor, then we can increase our multiple. That means if we add this remainder to the number that we have put here, it becomes perfectly divisible. So such a case is wrong. Now the next number. Now again this is wrong, because the remainder can never be greater than or equal to divisor, because according to the rule of division, the number that we put here should be the nearest multiple of this number or the number itself. If it is perfectly divisible, then only. So now the concept says either it should be perfectly divisible, or if not, then it should be the nearest multiple. Since 20 is not the nearest multiple of 5 with 26, the nearest multiple of 5 near 26 is 25. So the correct division should be 5 times and the remainder should be 1. So what we should learn from here is that our remainder can never be greater than or equal to the divisor. So the remainder always has to be less than divisor. It can be 0, it can be 1, 2, 3 depending on the divisor itself, but it will always be less than divisor. It can never be equal to the divisor. So now we will generalize this case. Let's see. So what I was telling you is that the remainder has to be less than divisor, but it can be greater than equal to 0. Okay, so when remainder can be 0, when the number is perfectly divisible by the divisor, and greater than 0, it depends on the number. For 5, for the number 5, what are the possible remainders? 0, 1, 2, 3, 4. For number 6, 0, 1, 2, 3, 4 and 5. Now for any number, the possible number of remainder is always less than the divisor. Now what Euclid told us is very similar to what you have been having a look here now. So let's have a look. So what Euclid said, A is equal to B cube plus R, which simply means dividend is equal to divisor into quotient plus remainder, where the remainder is less than the divisor and the remainder can be greater than or equal to 0. This is what Euclid's division lemma says, where this means dividend, this means divisor, this Q stands for quotient, R stands for remainder. This is very similar to this, not similar, in fact you can say that the approach, the concept is exactly the same to this. Now we'll start with the problem solving. This was the basic introduction about Euclid's division lemma, and the set of steps that we are going to use, we'll name it as Euclid's division algorithm. Now let's start with the problem solving. Okay. Now the point is, what was the need of this Euclid's division lemma? Why we are going to, like, how we are going to use it? So the ultimate use of Euclid's division lemma in your course, in your syllabus, is to find the HCF of a number. HCF, all of you are well aware what is HCF. That is what you call highest common factor. This is what we call HCF. So what are the methods that you are already aware to find HCF? One is prime factorization. Some of you might not be very well versed with that concept, but we'll be discussing that also in this chapter, so you don't need to worry. The other concept is by division method. I hope that is quite similar to prime factorization thing, but that division method in a different way will be used here in terms of Euclid's division lemma. Now we will focus on Euclid's division lemma now, that how to find the HCF with the help of Euclid's method. So let's take an example first. Let's say I have to find HCF of let's say I take the first question as find HCF of 117 and 45. So out of two numbers, what are the possibilities? One will be smaller, one will be greater, or both the numbers will be equal. So in case of equal numbers, we will not be finding HCF. So such questions you will not be getting. So but now let's talk about this case. So we'll take greater number, since here 117 is greater than 45, we'll apply the same rule, that dividend is equal to divisor into quotient plus remainder. Just remember this rule. This is so simple, it will be very easy for you to understand now. So I will take the number 117 as, the larger number has to be taken as a dividend, 45 as the divisor. So when I divide 117 by 45, in 2 times I get 90, so the remainder is 27. So as per the rule, the dividend is equal to the divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. In the next step, now try to understand. Have a look very keenly and very sharply. Now the divisor of this case becomes the dividend for the next, and the remainder becomes the divisor. Listen it once again. The divisor of the first step becomes the dividend for the next step, and the remainder of the first step becomes divisor for the next step. That is, now 45 becomes the dividend and 27 becomes the divisor. Now again divide it. So now 1 time 27, so 18. So now again dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient is 1 plus remainder is 18. Now again the divisor of this step will become the dividend for the next, and the remainder will become divisor for the next. That is 27 is equal to 18. So when I divide 27 by 18, it goes 1 time and the remainder is 9. Now again the same step, divisor becomes the dividend and the remainder becomes the divisor. So 18. Now since 9 2's are 18, it is perfectly divisible, so the remainder becomes 0. And the step at which the remainder becomes 0, the divisor at that step is your HCF. I hope all of you understood this. This was a very simple case. In case not, we will discuss few more problems. Have a look at this. I hope it is very clear. I'll just tell you once again, I'll dictate what I've done. I've taken the greater number as the dividend, the smaller one as the divisor. I have divided it. I have simply applied the rule that dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. So the divisor for the first step becomes dividend for the second. Remainder for the first step becomes the divider for the second. Again the same rule, and the rule kept on going till the time the remainder becomes 0. And this step at which the remainder becomes 0, the divisor at that step is what we call HCF. Now let's take another problem. Okay, now let's take another problem. Find the HCF of 210 and 55. Again we will go with the same method. The process and the method will be the same. And what was the method? That dividend is equal to divisor into quotient plus remainder. Now again, since the greater number has to be taken as the dividend, so since here 210 is greater than 55, so dividend is equal to divisor into quotient plus remainder. So let's find what will be the quotient and remainder. So it goes 3 times, you have 165, it becomes 45. Now, so dividend is equal to divisor into quotient plus remainder. Now, as discussed earlier, as told, the divisor at the first step becomes the dividend for the second, and the remainder for the first becomes divisor for the second. Let's have a look. So the divisor for the first becomes dividend for the second, and remainder for the first becomes divisor for the second. So again applying, so 45 dividing 55 going 1 times, you will give you the remainder of 10. Again applying the same, the divisor becomes a dividend, the remainder becomes a divisor. 45 by 10 it goes 4 times, the remainder is 5. Again the same, the divisor becomes a dividend and the remainder becomes a divisor. So 10 is perfectly divisible by 5 and the remainder becomes 0. And the stage or the step at which the remainder becomes 0, the divisor at that stage will give you HCF. Do not get confused whether 2 will be the HCF or 5. Always remember that the divisor at the last step will be the remainder at the step preceding to this. Acidic पहले वाले step में it will be a remainder. So you don't need to worry about that. You don't need to get confused. Always remember the HCF, the divisor here will be the remainder here. So do not get confused. Just cross check. 2 will not be the HCF. Do not get confused. The divisor at this stage becomes HCF, and do not mix up the thing. Let the rule be dividend is equal to divisor into quotient plus remainder at every step. Do not mess it up. Okay? I hope you understood. Let's do one more problem now. Okay. Now we'll take slightly bigger number. To find the HCF of 4052 and the other number is 12576. Again the rule becomes same, the rule is same, that since 12,576 is a bigger number, that will be taken as the dividend. So 12576, this is 4052. So when we divide this, it goes around 3 times, that is 12,156. So you get 420 as the remainder. So dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. Are we done with this? Now, as of you remember, the divisor at the first step becomes the dividend for the second, and the remainder at the first step becomes the divisor for the second. So dividend becomes 4052 and divisor becomes 420, and it goes 9 times. So you have 4052 is equal to 420 into 9. So let's do it. So 420 into 9 will give you 9 2s are 18 and 1 carry 9 4s are 30. 3780. So let's divide it. What you're going to get here is 4052 9 times. It goes by 420 and you have 3780. So 2 15 8 you got 7 and you got 2. So now again the rule is same. Dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. The same step. Divisor becomes a dividend, the remainder becomes a divisor. So the divisor becomes the dividend and the remainder becomes the divisor. That is, now let's divide it. Now what we are going to get when you are going to divide 420 by 272, that will go one time. You have 272 out of 10, 2 you got 8, 11 minus 7 is what you got 4 and 1. So you have dividend is equal to divisor into quotient plus remainder. That is 272 into 1 plus 148. Again the same step. So 272 is equal to 148. Clearly it goes one time, but the remainder now becomes 124. Again the same. Now 148 is equal to 124. It clearly goes one time, plus the remainder is 24. Again the same. It becomes 124 is equal to 24 into 5. That is 120 plus 4. Again, that is 24 is equal to 4 into 6 plus 0. And when the remainder becomes 0, the divisor becomes your HCF. I hope the concept was easily explained, and I hope it will be very easy for you to execute this in terms of your problem. At every step the concept has to be the same, that dividend is equal to divisor into quotient plus remainder. This concept, apart from this, that the divisor at the preceding step becomes the dividend for the next, and the remainder at the preceding step becomes the divisor for the next step, till the time your remainder becomes 0. And the step at which the remainder becomes 0, the divisor at that state or that step gives you your HCF. Now, I'll be discussing one problem from the textbook NCERT. The first exercise of the chapter. Okay, so the first exercise, the first question says, using Euclid's division algorithm, find the HCF of. There are three parts of this. We'll be doing two, the bigger numbers. So let's start. Okay, so the first part says you have to find the HCF of 135 and 225. So the concept remains the same. The bigger number becomes the dividend, the smaller number becomes the divisor. So when you divide 225 by 135, it goes one time. So the difference becomes the dividend is equal to divisor into quotient plus remainder. So it becomes divisor into quotient plus remainder. As you all remember, the divisor at this stage becomes the dividend for the next, and the remainder becomes the divisor. That is 135 is equal to 90. Now clearly 90 goes one time, so 1 plus the remainder becomes 45. So again the 90 becomes the dividend, and the 45, the remainder here becomes a divisor, and 45 twos are 90, so the remainder becomes 0 because 45 is perfectly, like 90 is perfectly divisible by 45. So the divisor at this stage becomes your HCF. Now, I hope this was clear. It was very simple. Now we'll move to the last part. The other set is 867 and 255. So again the larger number becomes the dividend, and the smaller number becomes the divisor. So let's divide 867 by 255. So it goes 3 times, it becomes 765. So you have 102 as the remainder. So dividend is equal to divisor into quotient plus remainder. So the divisor at this stage becomes the dividend for the next, and the remainder becomes the divisor for the next. Clearly 102 goes 2 times, that is 204, and the remainder becomes 51. Now 102 becomes a dividend and 51 becomes the divisor. It clearly goes 2 times, leaving a remainder of 0. So at this stage your 51, that is the divisor at the last stage, becomes your HCF. Now I hope the concept was quite clear to you. I'll be uploading an assignment about this very soon. Not very soon, in fact just after this video, or along with the video I'll be uploading the assignment. So go through these questions, and I hope you will face no problems in solving the assignment, or in case of any doubt or queries, you're most welcome with your